Today, we're going to install Ubuntu 14.10 Desktop Edition with GNOME. So we've got our desktop computer. This is the ASRock X99WS 10 gigabit, which is our high-end workstation. That's got the 5960X, and then it's got the Micron 16 gigabyte DDR4 kit. This is in our handsome and lovely NZXT Phantom 530 with the NZXT 700 watt power supply. For the graphics card, we're actually going to set up both an AMD and an Nvidia graphics card with the proprietary drivers. The Nvidia card, we're actually going to use a 960 because the 9 series cards are a little strange to install. Not really, but if you just go to Nvidia's website and download the file, there's a 50-50 shot you're going to have a bad time. So we're gonna go into that a little bit more. But that's what we're running for the hardware. So it's pretty high-end hardware. This is workstation hardware. We're also running a Plextor M.2 SSD because those are pretty fast. So M.2, the M.2 interface is much faster than SATA. So that's always nice because we're impatient and we don't have all day. So the first thing that you want to do is go in your boot order and make sure that you're going to boot from your USB stick. Now, there's tons of videos online for making a USB stick. If you're on Windows, honestly, the easiest way is to use Win32 Disk Imager, and just use that to take the ISO that you download from the Ubuntu website or any Linux distro. Honestly, for any Linux distro that you're making on Windows, you should just use that. On Mac, it's pretty easy. You just take the ISO, and it sort of just knows what to do, so I don't think you'll have any trouble with that. The thing that's the trick here, though, especially if you're dual booting, is one, you want to make sure that you unplug all of your other hard drives. It's too easy to accidentally screw up your Windows installation, especially if you're kind of a noob. If you're on a laptop and you want to split your partition so that, you know, half your hard drive is Windows and half your hard drive is Linux, we are going to cover that in a separate video. It's not too hard, but you've got to make sure that you back up your stuff before you do this. So please, please, please make sure that you back up all of your stuff before you do this, because sometimes things don't play nicely between the two. But if you unplug your hard drives, you will basically be okay. The other trick is if you're running Windows 8 or Windows 10, you'll want to make sure that you do the UEFI boot. And so the name of my flash drive is PMAP for whatever reason. And I've got a choice of USB boot or UEFI boot. This is really subtle, and a lot of things miss this, and this can lead to a bad experience for you with Linux. USB boot is the old legacy, like MBR style boot, and UEFI is the nice new modern boot. You'll want to do UEFI, especially if you're running Windows 8 or Windows 10. If you're running Windows 7, I'm sort of on the fence as to whether I think the MBR boot, the USB mode, or the UEFI boot is better. Honestly, I'm not sure. I tend to say that the MBR boot is better just because it's consistent with the way that Windows 7 boots. So I don't think that it will mess with your Windows 7 installation either way. But on Windows 8, on certain machines, by doing the MBR boot along with Windows 8 being in UEFI mode, it can mess with the keys that are stored in the BIOS. And so Windows will say, oh, secure boot's disabled, or oh, secure boot's broken, or whatever. And modern Linux distros should boot in UEFI mode. Some distros don't boot in UEFI mode, so you got to keep that in mind. You should look for UEFI support on the distro that you burn to USB. And so this is like a really long, convoluted thing, but sorry, but this is just the way that it is. And so in this case, we're going to go for UEFI. So I'm going to just set that, and then I'm going to do F10 save and exit. All right, this machine's going to reboot, and then we're going to install Ubuntu. I've already got Ubuntu on here, but we're just going to install it again because that's just how we roll. If your BIOS is or UEFI is grumpy about boot order, you can also hit your boot menu and make sure that you pick the UEFI option. I'm just going to arrow down to install Ubuntu Gnome, although you can try it off USB if you want. Okay, we're at our install screen. I'm going to pick English because I don't really feel like installing it in Esperanto today. It is connected to the internet, but it doesn't know that. That's fine. I'm going to go ahead and check install third-party software. This is going to be a recurring thing that you're going to see in Linux. The philosophy of Linux is we only really want open and free things, but we also want to run Netflix. Netflix and other stuff uses non-free technology. So like MP3s technically is a non-free technology in the vernacular of open source. And what that means is that it's protected or encumbered by patents and other IP controls. And so even though the algorithm for MP3 decoding is published, under US law, it may not be legal to possess that without a license. It's kind of pedantic, but corporations don't really want to get in trouble for doing this. Because Linux is a coalition, not really, but because a lot of these kinds of things are programmers working in their free time, not necessarily maybe working commercially. The software that is non-free in that sense is sort of segregated from everything else. And a lot of the time, that kind of stuff will come from countries that have weaker rules. So like the EU and the European Union, software patents are not really a thing anymore. And so things in the US that are pieces of software that are patented and protected by software patents don't really have the same protection in Europe. And so this is what that means. It also means that drivers like the AMD Radeon drivers and for their graphics cards and the Nvidia graphics cards drivers, those drivers are really drivers that are meant for Windows but have been sort of hacked by Nvidia and by AMD to run on Linux, and they are closed source. No one can see the source for those drivers, and because of that, it makes open source people uneasy. And that's when you see free software, free as in speech, not free as in beer. That's what they mean. And so free as in speech software means that you can see the code and you are free to modify it and redistribute your modifications and that kind of thing. And with proprietary software like MP3 decoding, even though it's open, you still don't get the license to do with it what you want. And then with proprietary software like your video drivers, you don't even get the source code. There are open versions of drivers that are available, but those tend not to be as functional. And so like if you're going to run Steam, you pretty much have to run the closed source drivers because that's what they're testing against. And that's what supports all of the features necessary to actually run the games. So it's a side thing, but if you're installing Ubuntu, you probably didn't know that, and I thought it was kind of important to sort of walk you through that the best that I can. It's a little conversational. It's not, it's not the whole story, but hopefully it's enough that you can get by. All right, let's go ahead and hit continue. All right, on this option, hopefully the only drive you have plugged in is your drive that you're going to install Ubuntu to. You'll get some options. Now, in my case, because I've already got Ubuntu on the other drive, it's like, what do we want to do? I'm just going to do erase entire disk and install Ubuntu Gnome. Now, you have the option of encrypting the whole disk. This is like TrueCrypt level encryption. And you also have the option of using LVM, or you have the option of doing something else manually. Because you're a noob, I'm just going to say erase the disk and install Ubuntu Gnome. The other options, LVM stands for Logical Volume Manager or Linux Volume Manager. And it will let you sort of seamlessly grow your partition onto multiple disks. And so, like if you have a 500 gig disk and you're like, oh, that's not enough, I need another 500 gigs, you can use LVM to make the partition such that it's basically across both disks. It's not RAID, it's just, it gets to the end of the disk and then it goes to the next disk. It's not RAID 0, it's not RAID 1, it's not RAID anything. It's just, it's maybe close to JBOD, just a bunch of disks. So LVM can be kind of handy, but because this is your first install and because it doesn't really matter, we're just going to erase the entire disk and install Ubuntu Gnome. There's other cool options under something else that lets you install with alternative file systems. So there's a bunch of file systems that are available. What's a file system? Well, on Windows, it's pretty much NTFS. Memory cards use exFAT or FAT32. This is just the format that stores the files, like how the files are on disk. There are new up-and-coming file systems like BTRFS, which has a lot of really cool features, but it's not really super stable yet, so I wouldn't recommend it. There is one other file system that you can install to, which is XFS, and XFS is an absolutely stellar file system for like web servers and things like that. Any kind of file system that has loads of teeny tiny files, it's very, very good for that. Better than ext4, I think. And ext4 is the current version, sort of de facto file system on Linux. It's pretty fast. It doesn't really have a ton of features, but it's not a bad file system. So we're just going to hit install and run with it. It's like, oh, it's going to nuke everything. I suppose that's fine. It's actually installing in the background, but it's going to ask you some questions now while it's installing in the background. So time zone, keyboard layout, it's where you would set Dvorak. Once you want your username to be, and then here's an option to also encrypt your home folder. This will encrypt your home folder with your password. So you can have a system that's entirely encrypted, and then your home folder is also encrypted, or you can just encrypt your home folder and nothing else. I'm not going to bother because this is just a demo. And then this will install. You get a cool little slideshow, so you can, gives you something to do while it's installing. It would actually be good to go through the slideshow because it's talking about the different software available for doing things like Shotwell and Rhythmbox and that kind of thing. All right, the installation's complete. Let's go ahead and restart. Now, while we're waiting for it to restart, you probably could go ahead and hook up your hard drives. Because you didn't have your hard drives attached, it's up to your UEFI to pick which device you boot from. Now, you can configure the boot manager. My favorite one is called REFIND, Refined. I'm not sure if that's, it's kind of funny. It's sort of an EFI boot manager thing that lets you pick between operating systems. But honestly, if you're nervous and it's slightly weird, it's just easier to hit the BIOS key, F8 or F11 or whatever, to pick the device that you want to boot from. That way you don't have to mess with either operating system. It's also probably easier to configure Linux to let you boot from Windows. The problem with that is that will sometimes, if not every time, interfere with secure boot. So secure boot, in order to understand it, secure boot is the secure handoff between the UEFI and the operating system with nothing in the middle. And so by going to the Windows boot, or going to the Linux bootloader, sometimes Windows will detect that as like, oh, this is unsigned or whatever. It's supposed to be signed, and the key is supposed to be trusted, and major distributions are using, a signed EFI key to try to get around that. But by and large, just using the BIOS to say, oh, I want to boot from this operating system, oh, I want to boot from that operating system, works better. And almost all UEFI supports sort of keeping track of multiple sets of secure boot keys, so I don't think you'll run into a problem there. Now, you may have to go back into your UEFI and pick the device that you want to boot from. And we're logged in. That's great. Welcome to our new environment. Now, there's not really a lot installed. You hit up in here and you get some icons and blah, blah, blah. This is, you could kind of watch the Linux vernacular video. It's a little rough just because I was like, oh, let's do it conversationally. In hindsight, that may have been a mistake. This is your desktop environment with the GNOME window manager. And so, just sort of some quick things. If you just start typing stuff in, terminal, you can run the terminal program. You can run, we're going to run, Rhythmbox for music. There's no music. I don't have anything installed here. We're going to run, Firefox. And so you can go and install a whole bunch of stuff. So this is your settings widget, and you can configure how you want to do things. And so like notifications, the notifications in GNOME pop up here at the bottom. So I've just moved my cursor to the bottom there. There's also virtual desktops, which if we do this and then that, then I can do this, and then it's like, oh, there's some stuff here, and then you've got another desktop, and so you can, sort of toggle between them. Not really anything too crazy. There's one thing I'll show you really quick. I'm going to hit Control-Alt F1. Now we're at a text terminal. This is technically TTY1. It's like teletype terminal. Yeah, it's just a textual terminal, but you can log in here and move around the operating system. Now, strictly speaking, Linux is just the kernel. The kernel is the piece of software that separates the hardware from the software. And so the kernel is the thing that's like, these are the running processes on the system that you see. And there's not really a lot here. We can sort by memory usage, and maybe it gets a little more interesting. You can see GNOME Shell and Firefox and Update Manager and all these kinds of things. The kernel manages these running programs, access to the physical hardware, the physical devices, which things are cached in memory, how much memory is used, where things are. So it's a very, very comprehensive piece of software that is the platform from which all software applications run, but also provides an abstraction layer for hardware. So like if you're running AMD CPUs or if you're running Intel CPUs, those CPUs don't even necessarily agree on whether the most significant bit in binary words comes at the beginning or the end of the disk. That's big endian or little endian, at least historically. But the kernel takes care of abstracting all of that so that software doesn't have to really think about that most of the time. The software is just able to say, oh, I'm going to allocate an integer. Oh, I'm going to allocate, a long integer or whatever. And it's all just sort of handled transparently. Or things like I need to access the hard drive, or I need, whatever it is. The operating system, the kernel of the operating system, sort of handles that abstractly. And so everything else is like the GNU utilities, and that's why RMS was saying, oh, GNU Linux, and it's really the GNU utilities plus the Linux kernel. And so the Linux operating system with the kernel and the GNU utilities is really all this stuff that's running underneath. And the graphical environment, which you can get back to if you do Control-Alt F7 on most distributions, it takes you back to the graphical environment. But if you know the command line commands, it's like aptget, install aptitude. Aptitude is a text-based package manager. It's very good. It's really a front end for the the actual package manager that's running on the system, which is dpkg, but we won't hold that against it. Apt is a utility for manipulating installed packages and that kind of thing. So we're going to apt-get install aptitude and then show you how to search for things with aptitude and that kind of thing, just so you know how to do it from the command line in case things go wrong when we're installing the video driver, because you can drop to the command prompt and apt-get remove whatever it was we installed that broke everything. We're going to go to root. Now on Windows, you may be familiar with like UAC, user account controls. On Linux, it's basically the same deal, and it has been since the beginning of time. Your normal user account doesn't really have permission to do much. And the way that you switch to the context of an administrative user is sudo, or sudo, S-U-D-O. You can also SU, but most distributions actually lock that account. If we cat /etc/password, these are the accounts that are on the system by default. Now, most of these are service accounts used by the system, but that first one, root, is the important one. On Windows, this is the administrator account, and awesomely enough, on OS X, Mac OS, it is also root. The root account on Mac OS is usually completely disabled, but the first user on the system can assume root's identity with SU or sudo. And so that is the administrative user that lets you do things. And so when I tried to apt-get install just then, it wouldn't actually let me because I was not running in the context of an administrative user. So how much damage I could do was really just relegated to my own folder. And so if you see the path here, it says /home/w. /home is where all the user accounts are kept, except for roots, which is /root. /w is my home folder. And so if I'm running as the normal user, pretty much the only thing I've got permission to is this folder, and there's another folder called temp, TMP, that I would have permission to. That's just a temporary location, and actually that location is, in most distributions, cleared on reboot automatically. So that's sort of how things work. This is pretty much the same way that it works on OS X. This is similar to how it works on Windows, but Windows is sort of just getting the hang of multi-user, whereas Linux has been multi-user from the beginning. This is called a multi-user architecture, even though there may only be one user on the system, because it's about privilege separation, so that this program running is this person, and this program running is this person, and this program running is that person, are all sort of sequestered. And if there's a security issue with one of those programs, it's just relegated to that corner of your system for whatever that program does. It's sort of a separation of privileges, which is a good thing. That's sort of how things are working underneath the hood. There's more than one terminal too. You can just do Alt F2, 3, 4, 5, and get to more than one terminal, so that you can run multiple commands. There's also job controls, so you can actually run multiple commands from a single terminal, but we don't need to get into that for the purposes of this video. Of course, if you only want to remember one shortcut, you can also do Control Alt F1, F2, whatever. But if you're already in the terminal, you can use Alt, but no one really cares. Control Alt F7 to go back to graphical. So how do you install software? How does that work? Well, let's go look at that real quick. Now, you'll recall that I installed Aptitude when we were in the terminal. I can run that from the terminal, and it gives me this interface. And it's, oh, there's actually 102 security updates. That makes sense because we just installed it. There's some upgraded packages. This will show me installed packages, not installed packages, and tasks. Now, tasks are groups of packages to make it easy. So you can just say aptget install DNS server, and it'll go and get, you know, all of the packages necessary to run a DNS server, of which there are quite a few. So there are quite a bit of tasks here that let you, it's like if you're going to do LAMP, software development, that kind of thing, you can just run LAMP and Apache and, you know, all the stuff, and it'll just, you aptget install LAMP server, it'll just go get all that stuff, which is nice. So this is handy for just browsing packages, and this works from the command line, so you don't even have to have a working graphical environment to do stuff. But it's a little clunky, so let's look at it in the actually it's not clunky at all, it's very good. But if you really want to use the graphical environment, you can just go to this and browse, and this is the list of all the programs that are on there. Ubuntu Software Center is the graphical one, and sometimes the graphical one can be a little weird, so you might be able to find a package with this and you'll tell the graphical thing, hey, install that. Something goes wrong, but if you drop to the command prompt and you install it there, it'll work fine. Steam has been that way on and off in the Ubuntu Software Center for ages, but apt-get install Steam always works fine. So this is like the App Store for Ubuntu, and I know that it's really, there are experienced people that would hear me call that an App Store and would probably crucify me, but that's probably the easiest way for me to explain it to you. Before there was an App Store, there were repositories, which, as it's more properly known, that store software packages for every different Linux distribution under the sun. There are different repository formats, so different distributions have different repositories. Ubuntu is built on Debian, and so Ubuntu shares a lot of the same repositories with Debian, but they also have their own. Red Hat has their own format, RPM, their own package format, and so they have their own repositories that go with that. But there are a ton of different Red Hat repositories for different kinds of software. Now, here's the thing, though, with Google Play and, you know, the Apple App Store, Google and Apple have final say-so. That's it. If you're not on the Google Play Store or if you're not on the Apple App Store, that's it. You're done. It doesn't work like that on Linux. On Linux, you can add different vendors to your list of repositories, and when you do, you add them with different priorities. And so like the officially supported Ubuntu repository might be the top priority, and then you can add another repository from a developer that, say, makes Dwarf Fortress or some other game that you really enjoy, and when you add that repository, it makes those packages available to you. But this is different than just willy-nilly downloading software off the internet. You really got to get out of the habit. On Windows and Mac both, if it doesn't come from the App Store, which the App Stores on the desktop platforms on those are really not very good on either Mac OS or Windows. It's better on Mac, but it's still not where it should be. Packages that are available on the App Store on those platforms suggests that it's been vetted and that it's basically stable. When you're downloading software from the internet, you know, it's you're trusting that software is not going to screw up your computer. That's a lot of trust. And so this package management system on Linux is actually superior to the way that it works on both Windows and OS X. You know, with OS X, Apple's got the walled garden of software. Theoretically, somebody's looked at that software and made sure that it's not going to mess up your system. That's probably true for like the iPads and iOS devices. Apple's really just getting into the swing of things with the desktop apps, App Store. And, you know, those applications are reviewed. Google really doesn't review them nearly as closely, and so that's maybe a problem. But on Linux, that's the way it's always been, with the exception that you can have more than one source of apps, more than one repository on your machine, and basically everything just works when you do that. And so the package management system on Linux is actually very robust, and I would say is more robust than what you get on Windows or even OS X. So we're going to go here and we're going to look for, let's look for a couple packages. Let's look for Chromium. All right, so we're going to install Chromium. Now, Chromium is like an open source. It's a version of Chrome that has all of the Google monitoring spying crap cut out of it. So if we do a lspci grep ATI, we can see that I got a Radeon 5770 installed. If we do lsmod grep Radeon, we can see that I'm running the Radeon driver. Now the Radeon is the open source one, it's not the proprietary one, so I'm going to have a bad time if I try to use Steam. So let's, I've got Chromium, I think that's still downloading. Let's look for Steam. Alright, so we have Steam. Do more info, can't find it. I don't know why, this is kind of silly, but that's okay. We're going to drop to the command prompt and do sudo aptget install Steam. Oops, I have to spell it right. It's gonna, oh my gosh, we got all this crap we got to install. Whatever, let's do it. Okay, with Steam installed, we basically just need to agree to the license. I agree. Now with Steam installed, let's hit activities and type Steam. Hey look, it's Steam. Steam's ready to go. Steam's not quite ready to go. The reason for that is that we're using the open source driver, which almost certainly doesn't work. We need the proprietary driver. We can go to the Software Center and then additional drivers, and it'll search for additional drivers. Now, since I'm using Radeon, it's going to find FGLRX and FGLRX updates. You want FGLRX updates. This one is the most up-to-date, and so we're basically just going to hit apply changes there. So you'll notice this process is a little different. You know, we talked earlier about how you don't just go randomly download software for your computer. That's a good way to mess it up. You want it to come through the repository. Now, if you're on Nvidia, the process would be a little different. You can do it this way, but the drivers from this won't be quite as up to date. We would actually want to add a new software source or a new repository that is a little more up to date than the one that you get out of the box. And so when we switch to the Nvidia graphics card in a few minutes, I'll show you how to do that. But for now, this is going to download and install the FGLRX updates driver. Now remember that we did the LS mod and saw that the Radeon driver was in use. And so when this is done, we won't be using the Radeon driver anymore. We will be using the FGLRX driver, which works better with Steam. Okay, that's done. We're just going to hit close and we're actually going to reboot. Now when the system comes back up, instead of loading the Radeon driver, it should load the proprietary FGLRX driver. Hey, it loaded it. But with the proprietary driver loaded, it's got HDMI scaling turned on, so I've got some black bars around my display. Blast. All right, let's see if we can fix that. It's overscan or underscan, depending on how it's documented in the driver. In the configuration folder /etc, in the ATI folder, there is a textual database of config. And so it's this AMD whatever database. So I'm just looking at the files in here. You can use gedit through the GUI to browse to /etc and then ATI to edit this file. It's in that folder. In here, it says TV overscan enable. All you gotta do is just change this 1 to a 0. But because the driver is running, and because this particular version of the driver is buggy, it doesn't save it. And so AMD does give you this AMD CCC LE Control Center. This is the AMD Catalyst Control Center that you're maybe familiar with. You can also just browse for this program. It's in the program list. You should be able to go to the display manager and then go to the display and actually turn overscan off. But for some reason, they've taken it out of the GUI. I've seen it in here. I don't know why it's not here. It seems really dumb that it's not here. But, you know, there it is. There's also this tear-free option, which I'm going to get kind of sidetracked on. I'm just going to go ahead and turn that on. This enables VSync for the desktop. And so what it does is with it on, when you drag windows and things like that, it'll trigger these movements on VSync so that it's not like tearing while you drag windows and move things around. So it ends up making things look a little better. Now, I can't actually edit that text file and have it stick. And when I reboot, the settings change because the FGL driver saves its settings on exit. And so that file is overwritten when I reboot, which seems like a terrible... I mean, that would be great if the GUI worked, and clearly somebody was thinking, we should save the settings to that file on shutdown when somebody manipulates it through the GUI. But the GUI's broken. The GUI doesn't let you change it. I don't know why. It used to, but it doesn't anymore. And maybe they'll fix that in more recent versions. I really hope they do. But for now, no, it doesn't work. Okay, with the display all set up, let's run Steam. While this is downloading, let's install Chrome so we can get Netflix. Now, Chrome is one of the exceptions to the rule. Normally, you don't really want to download random software from the internet, but with Chrome, it's okay if you have to run Chrome. Now, Chrome, you know, Chrome works for Google, so not well liked in the open source community. Not necessarily well liked, but I do like that we can basically there's a download, a 64-bit download for Ubuntu and Debian. So we're just going to download that, and then this file is going to specify the other files that it depends on, so we can just install Chrome. We'll just hit install here, because we opened it with Software Center. It'll know what to do. Let me show you how to also get extensions for GNOME. So like one of my favorites is Drop-Down Terminal, which you probably already know. GNOME shell extensions, not widgets, but close enough. And so we're going to allow, there's an extension here that runs in Firefox that will allow this website to basically install extensions. We're going to turn that on, and it's like, whoa, do you want to install that? It's like, yep, that's fine. And so that's going to turn it on. And then I'm actually going to turn off transparency because we kind of already get transparency. I'm going to change the height, since this is a 1080p display, to 700 pixels. And the default key above tab, which is actually backtick, not tilde. So that you can hit backtick and it's like, ta-da, drop down terminal. Now you can set up a shortcut key to bring up terminal automatically, but this is a little cleaner, I think. There's also another extension that does this called Gwake. Just out of habit, I use drop down terminal. If you like the OS 10 style dock, there's a bunch of different extensions you can get that will give you the OS 10 style dock at the bottom of the screen. The most popular one is probably Docky, but there are some others. Just you can browse the GNOME extensions. It's like dash to dock, workspaces dock, taskbar. Docky, I think, is something that you can get through the package manager though, because I don't think it's technically just a GNOME extension. So you can get GNOME extensions that change the way the top bar here works and the way that you interact with programs. You can get one that gives you a menu here instead of this activities link, so it's more like a start menu on Windows, but in the upper left-hand corner. So you've got some options. And hey, we've got Steam. Look at that. And we can even install Bioshock on Linux, available today. Well, actually a while ago now that you're watching this. So you can run Steam. But wait, there's more. Let me show you one more thing. There's another thing called PlayOnLinux, which is really just a front end for Wine. Now, Wine stands for Wine is not an emulator. It's a Windows platform for Linux. Not emulation, it's making the library and system calls on Windows available on Linux. It's really finicky. It's sort of 300, 400 level skill. But we're going to go ahead and do aptget install PlayOnLinux. And so PlayOnLinux is going to download all that crap, and included in the crap that it's downloading is the dependencies for it to download and configure Wine. And so PlayOnLinux can actually, there's a bunch of different versions of Wine. Wine can emulate 32-bit Windows or 64-bit Windows. And PlayOnLinux has a database of programs, games especially, that are sort of pre-configured. And so I'm going to show you a couple of steps that you can go through to actually get Skyrim for Windows up and running on Linux. Yes, you know, face-melting craziness. All right, so while that's installing, let's check out Chrome. But the big thing about Chrome is that it works with Netflix. And so as you can see, Netflix actually works just fine on Linux, with Chrome anyway, because it supports the necessary digital rights management or digital restriction management necessary to, you know, play movies on Linux. So there you go. Sweet. So I've got to agree to the license to use the Microsoft fonts. Okay, with PlayOnLinux installed, I'm going to hit install a program, and it's going to download a whole bunch of stuff. Now with the native version of Steam, whatever games are available for Linux, we can just go ahead and install. So like Trine works on Linux. About 20-25% of the Steam catalog is available on Linux. And so whatever games you happen to have bought that are available on Linux, you can just go ahead and install on Linux, and it'll be native, and it's more likely to be more stable. It's less likely to be problematic because you're running in the Steam client. This is what Steam's working on. This is what Steam's working toward, or what Valve is working toward. The games actually work really well. So Trine is perfectly fine. It's pretty stable. The performance is down to the graphics drivers. So depending on what version of the graphics drivers you're using, the ones that we're using here are actually a little bit older than the ones that are available on the AMD website. You can install a newer version, but really you should install from a PPA or from a repository of somebody who has updated. Ubuntu actually has, I think, 5 or 6 repositories available. The FGLRX-updates is generally the most stable one and is updated pretty often, unless you're on a long-term support release. But the long-term support releases are kind of squirrely around the proprietary drivers, and so the games actually will tend to run pretty well, pretty stably. But PlayOnLinux lets you run Windows programs on Linux, and so we're going to install another copy of Steam, but it's the Windows version of Steam, not the Linux version of Steam. But we're going to do that by just telling it we want Skyrim. Now we can tell it to install Steam instead of Skyrim, and that would work, but that's just for Steam. The settings preferences for Skyrim actually have Steam and a whole bunch of other things. So you can, in PlayOnLinux, you create sort of hard drive files that are, it's not really hard drive files, but you have a folder where your C drive for Windows is, because it's kind of like a virtual machine, but it's not exactly a virtual machine because it's not really virtualization. And so this is going to download Wine 1.7.36 for Skyrim. And a little bit later in the installation, it's going to say, hey, are you installing from disks or are you going to do Steam? And we're going to say we're going to do Steam. And so when it's created that, when we're adding other entries, we can specify that PlayOnLinux reuse the image that we created for this, or we can create another one. So you could actually end up with a situation where you've got more than one entry on PlayOnLinux for each of your games, and that's generally, like, you want to try to avoid that if you can. But there are some games that will only run under 32-bit wine, and other games that will only run under 64-bit wine. So it does take a lot of finagling and fiddling, more than it probably should at this point. But you can run Windows games under Linux, and Skyrim under Linux is sort of, sort of a big deal. I think The Witcher also works this way. I've never tried it personally, but some of the people on the forum report that it works. It generated some kind of an error, but it's telling us how to fix it. And so what we want to do is run this command, which is setting a kernel parameter, and it also wants us to place this in this file, etc. sysctl.d ptrace.conf. So basically it wants us to change that from a 1 to a 0. So because we ran the other command, it's changed. And because we changed it here, it'll be changed after reboot. So, alright, let's do PlayOnLinux. Let's do next. Let's do... I guess it wants me to reinstall the program again. Hopefully it won't have to download everything again. Okay, so now we've got Steam for Windows installed via PlayOnLinux, which is actually running Steam under Wine with some pre-configured settings. Now you can look through the PlayOnLinux program and see if it has presets, because usually there's a database of programs that basically are known to work with PlayOnLinux. So like, for example, BioShock Infinite is really problematic to get running under Wine and PlayOnLinux. But there's a Linux version of BioShock Infinite, so now it doesn't matter. But some of the other games just don't work. But Skyrim does actually work pretty well under PlayOnLinux. You can even install extensions and mods, although you're probably better off. It's really hard to cram all that into a video, but this is sort of the basic steps for getting that going. Now, there's one other thing I want to show you, and that is how to get going if you've got an Nvidia graphics card, like a 9 series graphics card with a proprietary driver, because it's kind of harrowing. You know, the mistake is that you download the drivers from the Nvidia website. Do not do that. There is a PPA that has pretty up-to-date Nvidia drivers, and so it's like, what's a PPA? How does that work? Okay, let's actually go to the Tech Syndicate forums. So this right here, this is what you want to do. This works really well. I haven't installed the graphics card yet, but we're going to go ahead and do this from the terminal. So let me actually open the Software Center so you can see what's happening. So we're going to go to View, or actually Edit and Software Sources. So you remember what I was telling you about the App Store, Well, these are other app stores that you can install software from. So the act of installing Chrome has added this under other software. And so we're going to drop to the terminal and run these commands because this is honestly easier to do with the terminal, I promise. We're going to apt add repository to that. And what that does is that connects, it downloads an encryption key that's associated with this particular repository so that we're sure that the software that we're downloading is software that this guy is saying is basically okay. This is way better than downloading crap from the internet. You remember when CNET could be trusted? And it's like, well, I could download this from, randomfiledownload.com and probably get a virus. Or if I download this from CNET, then I trust the program is not going to give me a virus unless the author has, put in a virus. Well, it's not really like that with CNET and download.com. But it's kind of like that here, except this encryption key is from the author, or there's some association with the author usually. The author is usually connected to the PPA or the repository that it's associated with. That's not always true, but usually there's some connection. So we're in a situation where we've just installed this new PPA, so we want to do aptget update, because aptget update will connect to all of the software sources that we have configured in order to see if there are any software updates. All right, so that's done updating, and then so we can come back here and do aptget install Nvidia-346 or 348 or whatever. Actually, I'm going to show you a different command. Aptitude search Nvidia -star. All right, and so you can see that there are actually, let's do less, so we can get paged output here. All right, so you can see that there's actually quite a few versions installed. 346 is still the most current one, but you can see that there's also 340, 331, 319, 310. So you've got some options to install if 346 doesn't necessarily work or has a bug or some other problem. So that's good. But if 346 was not the most current version, it would actually show you in that aptitude search Nvidia less. So you could install 348 or 350 or 352 or whatever it happens to be. Now the other thing I'm looking for here is if it's telling me that it's removing anything. Because I've got an ATI graphics card in here right now, but when we shut down and remove it in a minute, I'm not sure that I'm not sure if I need to do anything. We created a custom Xorg configuration file when we ran ATI config, and a lot of the time that's not there. Like you don't really have, like it's automatically done, and so it just doesn't run there. And so I think that when we boot up the computer with the Nvidia graphics card in it, that Xorg file being there will be a problem. You wouldn't run into that unless you were swapping video cards. So I may just go ahead and remove that file or rename it. And that will be closer to what you would experience when you were installing this for the first time. So if your computer had an Nvidia graphics card from the beginning, this would be the steps that you would want to do to install the drivers. The drivers that are in the same place as the AMD drivers are a little flakier than the one that's in this repository historically. Sad but true. Once this is done, we're going to go ahead and shut down the machine and then swap video cards. Hey, look at that. We're on the Nvidia graphics card now. Booted right up. Let's make sure that we're using the Nvidia driver. Hey, there's no overscan problem either. That's good. Oh, I can just hit the drop-down terminal as well. Look at that. All right, cool. The open source version of the Nvidia driver is called Nouveau. And so because we're on Nvidia, we're using the Nvidia driver. So we are in good shape. Okay, so you're up and running with Ubuntu. Now, there's all kinds of stuff that you can do from here. You can install Microsoft Office on Wine. We've got a great video on getting up and running with VirtualBox. You can run your Windows programs in a Windows virtual machine in VirtualBox. You can do it seamlessly so that you're moving your Windows around, and your Windows program, Linux program, it doesn't matter. You're using it seamlessly. It's like a coherence if you've used Parallels for Mac. But it basically means that as far as you're using programs in your desktop environment, the programs look like they're native. And so even though you're running a Windows program, it moves through your Linux desktop environment just like it was a Linux program. You'd have to check out the video it's better seen than described. It's really cool though. And basically, because it's a real Windows machine, you're not going to have any compatibility problems or any weird problems. The only downside is that a virtualized machine doesn't really have direct access to your graphics hardware when you're running it that way. So there's not really a good workaround short of putting a second video card in your machine and dealing with it that way, but it's a little too bleeding edge. It's not really super well supported yet. OpenCL, AMD cards with OpenCL soon, probably this year, will support proper virtualization, and so you'll get hardware acceleration. It's likely that you will get hardware acceleration through your Adobe Creative Suite and AutoCAD and things like that. Directly through OpenCL pass-through because of OpenCL virtualization, but it's not there yet. When that happens, you'll be able to run everything in VirtualBox and everything will be fine, but we're not there yet. And not necessarily VirtualBox. There are programs other than VirtualBox too. There are programs that are probably better than VirtualBox, but the particular video we did was on VirtualBox because that's also what's on FreeNAS, and so we're going to get a little extra mileage out of that video. This is the settings application that will let you configure your background and notifications and search preferences, and you can come in here to displays and configure your display. You can go to network and configure the network parameters if DHCP didn't come up properly. Configure sound, your tablet color, Bluetooth. This is sort of the basic control panel before you install anything else. You can also install other programs. If you're a developer, there's a program that I would encourage you to check out called PHPStorm. And so PHPStorm is a development environment that's really nice. It's commercial. It's $200 if you're going to use it commercially, or $99 if you're an independent developer. It's a really nice development environment, and so you should totally check that out. There are other, and that one's an example of another one where you just download it from the internet. But that one's okay. Most of the other programs you get from a PPA. So this is it. You're up and running with Ubuntu Gnome, and you've basically got a fully functional desktop environment now. You can install applications, sort of the psychology of how to install applications. You know that you don't just willy-nilly download applications from the internet. You know how to poke around in the settings. At this point, you should be free to explore the operating system, poke around, learn it. Come to the forums and ask questions at techsyndicate.com. I'll see you there. Over and out.